All right, let's start. Good afternoon, everyone. I hope you're all well. And in this first talk, I'm going to talk about GraphQL JS and DataLoader and how to get started with them with the right structure. Just to let me know, how many of you have ever used GraphQL before? Yeah, some of you. And DataLoader? Yes, 1, 2, 3. Yeah, cool. So I'm going to tell you what's that. I'll put the link of the presentation on GitHub, and you can see the code I'm going to show you there. My name is Thomas Pucci. I need to give some credits to my coworker, Tico. He couldn't make it today. We both worked on the subjects, on the slides, and we're both developers, mobile developers at BAM. We're here in Paris. And so what I'm going to talk to you today, I'm going to present a structure we use on a project in production. And we're going to focus on our server side only. In this talk, I hope will help you to perhaps solve some issues, some problems you have on your own implementations. The problems I'm going to talk about are problems we faced on a real project. And this project is it was our first project at BAM. It started 8 months ago. And yeah, we had to deal with a lot of issues because we didn't know about GraphQL at the time. And now it's quite a big project. It's 80,000 lines of JS code. And I'm going to show the structure we use in production. The problems we needed to solve is first unmaintainable custom routes. As we talked about it, GraphQL is great because I remember on the project, after a few months of the REST framework, we ended up with tens of custom routes. It was unmaintainable and very hard to maintain. With GraphQL, you have one smart endpoint, as Warren said, and you only deal with one route. The second issue we faced was test splits. The thing is, we first put all our logic in our resolvers. I'm going to show you about that later. And we use an ORM, an object relational mapper. And the thing is, doing so, we were not in control. We used the framework, and unit testing was hard. Perhaps we needed that because we wanted to protect ourselves from bugs, from regressions. And the thing is, you asked about this previously, how to optimize a GraphQL server. We didn't have any idea how to do that. And for example, using an ORM at the beginning, it's optimized 90% of the time our queries because it's basic queries. But when you need to do joins and stuff like this, and it became harder and harder to optimize. So the structure is this 3 layers approach. We have 3 layers: a presentation layer, a business layer, and a data access layer. And I'm going to talk about 3 of them. And the first one is the presentation layer. This layer terminates your HTTP and your WebSocket requests. This is where you expose your server. This is where you present your server to the world, to your clients. And so, for example, you have a client doing a simple query with headers, with authorization tokens. You're going to end that in this layer. You're going to authenticate your user, and you're going to pass his request and give it to GraphQL. Let's start with a server.js file. Here we use a core server. This is the next generation of Express servers. It's a minimalist server. So if you need more of the core, you need to import more packages. So here we import core router and a core body parser. We're going to instantiate our application, instantiate our router, and ask our application to use our body parser. We're going to then ask our application to use our router middleware, its root, and we're going to check the methods, parse get methods. And we then start our server simply on our 3000 port. Now we add GraphQL. We're going to import GraphQL middleware. It's another package. And we're going to import our GraphQL schema. We talked about this in the previous presentation. I'm going to talk about this later as well. Let's try to import it. And we give everything to our GraphQL Core middleware in a post route, which is here /GraphQL. In this post route, you see that we use our core context and we return our schema, our executable GraphQL schema, and the context. The context is acquired from the user and its roles. This is something we can get from utils functions. Here, this is get viewer and roles. And you can see that here I authenticate my user using the GWT framework. So you can see that get viewer and roles are some methods imported, and we splitted these files like this. This is the end for the presentation layer. I'm going to talk about the schema. This is where GraphQL lives. Actually, GraphQL, this is our interface between the presentation layer and our business layer, or the domain layer, as Pierre talked about it. This schema, we're gonna describe our types, we're gonna describe our resolvers, and tell GraphQL where to retrieve data. So in a query.jql file, JQL means graph query language, we can define types. So for example, in this file, I can define a cat query. With a given ID, I will return a cat. And I can define an all cat query, and it will return all my cats. In a query.js file, I'm going to import everything from my business layer. I'll talk about this later, all right? And I'm going to tell GraphQL where to resolve the data. On my all cats query, I will simply return my catbusiness.load_all method. And on my cat query, I will simply return my catbusiness.load method. And you can see that this file is actually pretty simple and pretty clear. It's not that big, and we only are redirecting our resolvers to the right method. This is schema.js files. This is the utils files to gather all our type definition, all our resolvers. I'm going to click on these slides. You can find the code at the end of this presentation on GitHub. I import all my resolvers, and I make with my type definition, my resolvers, an executable schema, which I imported before in my presentation layer, if you remember. All right, let's talk about the business layer. This is where you're going to define all your business rules, all your domain rules. And this is pretty simple. This is only ES6 classes. And this is where you're going to define scopes, given a given context and a given user. Who is allowed to see what? And is he allowed to see all the fields you required? Or is he allowed to even see the object you're constructing? And so, for example, if I query one cat, I'm going to construct a cat object with a constructor. So this is our catbusiness.js file. You can see this is a classic ES6 class with a constructor, our load method, and the load method, which I used before in my schema.js file. In my load method, I check if I have an ID. I will ask my data access layer to fetch data. If I have data, I will return a new cat using my constructor and my context, my viewer, my authenticated user, and its roles. Inside the constructor, I've got a viewer can see method. I'm going to check that the viewer owns the cat, or is an admin, or is a vet, or is a friend of mine. And if you can't see that, I'm going to throw an error. Then I simply build the fields of my object. And for some reason, if it's an admin or a vet, I'm going to add another field. This is the identification number. Not everyone is allowed to see this field. And I'm going to check that in my business layer, because this is a business rule. All these utils functions are imported from other files. And this is where we found this solution very testable, because we keep files with their own responsibilities. So unit testing was, in our case, pretty easier. I'm going to talk then about data access. I'm going to talk about what is in between business and data access layers later. The data access layer aims to fetch our data. This is the link to our database. So on our previous calls, cat data access dot get by ID method, we're gonna ask our layer to fetch one cat, simply as this. In this file, for example, this is where I'm going to define my methods. I'm going to import and I'm going to use Knex. Knex is a query builder. So it's not an ORM. This is something that helps us building queries, building SQL queries. I can have a get by ID method. It's pretty simple. I'm going to just await my DB to return the first cat with a given ID. I've got a get by a list of IDs method. I can have a get all method, and I can even have more complex calls. Get by fuzzy name. For example, I can use more advanced features from here. This is PostgreSQL. More advanced functions such as the Levenstein function or Dimitrov function, which will match my search with something that sounds the same, but not exactly the same when it's written. This is something we couldn't do with an ORM. We couldn't, because we first used an ORM, and optimizing our queries was meant to doing raw queries. It was very hard to maintain. Here we have simple query builders that do some really cool stuff. You can do here domain-driven development. Your method names is something that everyone can understand. Get by fuzzy name. All right, we're going to do an example query on this structure. I'm going to query me, my friends, my friend's cat, my friend's dogs, and all these pets party hats. I can read on your faces that you're very excited to do this query. So I'm going to just start this server and make this query, all right? And what happens is that I told each my resolver where to fetch the data, but a resolver is very selfish. They want their data now. So if they loaded a friend and retrieve a list of IDs, they're going to fetch each of my cat IDs, each of their party hat IDs, one after the other. And I'm doing here like, I don't know, tens of round trips to my database. This is really not optimized. And I can assure you, when you need to do this query on your home page and you have hundreds of users, you hope and you finger crossed that your server won't burn. So what happened? I told you what happened. We made a lot of round trips to our database. Each of these rows is a round trip to our database. One optimized version is to tell our resolvers, hey guys, wait here. We're gonna do group queries. And this service is called DataLoader. An optimized version of our structure is this one. We start our server, and we only do 4 round trips to our database. Each resolver needs someone with their ID. DataLoader, we gather all these IDs and group our query. So what do we need to change to add data loader on our structure? Data loaders live here in between the business and the data access layers. These problems I told you about is known as the N+1 problem. In our catbusiness.js file, we're going to import data loader. Data loader is made by Facebook, by the way. Yeah, they're great. We're going to create a getLoaders method. Inside this getLoaders method, we're going to create our data loader. Here we have a byId loader, and this is the only thing data loader needs. With a given list of IDs, you need to tell him which method from the data access layer he needs to call. So with a given list of IDs, we're going to call our getDataAccess.getByListOfIDs method, and this is simply this. We can have another object, another method called prime loaders. For example, if someone needs to load all the cats, no need to get all the IDs and make a group query. We simply use our load all method from the data access layer, and then prime the data into data loader. So we're gonna cache our results, all the results, into data loader. In our server.js file, we're gonna import everything from our business class, and we're gonna instantiate our data loaders inside our router / GraphQL post block. So data loaders aims to cache data per queries. So I mean, if two users is doing each one query in the same time, there's no way one user is going to interfere with another user because they have separate data loaders. When I first instantiate my data loaders, I give it to the context. So in the context of each resolvers, they all have and share the same data loader. In my cat business file, back to it, I will simply modify one line. In my .load method, I'm going to say data is no longer equals to my data access get by ID. This is equals to data loaders.cat.byIdLoader.load. This is the only modification I need to do in the load method. In the load all method, I still get all the cats, but I prime the results into my data loader. So if in the future, one resolver needs one cat, we won't have to do a round trip to our database because we have already fetched all the cats. I'm going to cite one coworker. He told me that before the structure, a ticket took us a day to complete. After the change, only 40 minutes. Why that? Because the thing is, we separated each responsibilities in our server into separated files. This is easily unit testable. And when you think about how to do a feature, this is pretty easy when you have when you know where to do your modifications. So yeah, in summary, we have a lot of short files, but it's maintainable and it's optimized. We realized that we didn't need an object relation marpers. And why that? Because the object part, is something that you can easily make with a AS6 constructor syntax. It's very simple. The relational part is something that is already made by GraphQL, defining your schema and the type definitions. And we realized that we only needed to do the mapper side, the mapper part of the ORM. And this is where we used Knex and our query builders. And finally, what I want to say is DataLoader improves our performance with a little investment. with some few modification, we made only 4 round trips instead of tens of round trips to our database. The next steps, if you're interested in how to get started with both of them, and I don't know, perhaps recreate this example, I'll put the link to the slide on the meetup page. And I wrote a tutorial about it. It's called Getting Started with Apple 7, DataLoader and Knex. And this is something that you can develop for 2 minutes, and you have some checks that check your work. And if you're inspired by putting this structure in production, we have a bam/bam API on GitHub with all production-ready code. Thanks for listening. I hope you enjoyed this talk, and I'd be glad to answer your questions.
Questions?
Hello.
Hey.
First, thank you. So you told us about the n+1 problem, and you solved it with 4 queries. Is it possible to optimize specific GraphQL queries so you only make one? You do the joins in the database?
Exactly, because at some point, if you have a specific query and you always need the same data, and you don't need data loader, you can still access your data access layer directly and use a method that would do the joins. Knex is really cool doing that. You can do, I don't know, for some of our methods on our project, we use 15 joins, and it works like a charm.
Nice, Rob. It's a bit out of topic, but what software do you use for the presentation? Because I really like the way you highlight the code.
It's called Spectacle, I guess. She helped me with the slides, and melodrama scripts.
What?
Here.
Can you zoom in?
The slides is on GitHub as well, so you can look at the package.json file.
Thank you.
Yeah, well, thank you, everyone. Yeah, I will enjoy my lunch now. Cheers.